All right, what's up? What's up? What's up? Really quick, I want to just make this video going over the quiz. Everyone should have your quizzes back. You can see your grades, but for some people, it's really valuable just to hear someone explain what we're doing. Okay, so let me explain the answers to this quiz. Now, first things first, explain how a base unit is different than a derived unit. What I was really looking for here is for you to explain the difference in that derived units are algebraic expressions of base units, right? Base units are SI standard units. They can be manipulated based off of metric prefixes, but derived units are combinations of those base units, right? Like density, meters, not meters, mass over volume, so grams per cubic centimeter, or speed, meters per second, right? So that's base unit versus derived unit. The next question here, how many kilometers are in 1.76 times 10 to the 6th millimeters? This one tripped up more people than I thought it would. So let me explain. I'll work this one out. But remember Mr. Lee's golden rule, always start with what you know. So I know I have 1.76 times 10 to the 6th. Put that over 1, right? So I have this in millimeters, and I want to convert this to what? I want my answer in kilometers. Kilometers equals question mark. Okay, so in order to convert to kilometers, I first need to find that home base of meters, right? So I need to go 1 meter is equal to 1,000 millimeters. Those millimeters are going to cancel out, exactly, right? And then I go from meters to kilometers. 1 kilometer is 1,000 meters. So then you multiply this expression, you take the numerator, 1.76 times 10 to the 6th, you divide it by the product of 1,000 squared, because that's 1,000 times 1,000, right? And then you would be left with the answer 1.76 kilometers, okay? That would be the answer to problem 2. If you're still confused about that, hit me up later. But continuing on, whoop, clear all my drawings, X, let's go. Continue on. Continuing on. Identify both a physical change and a chemical change that could happen or that could be done to a piece of paper. This one was pretty easy, straightforward. Hopefully you, I think most people got this one correctly. Sorry. Burning a piece of paper, letting it rot or decompose would be chemical changes, right? Because you're changing the structure of what you're dealing with. But then cutting, folding, throwing it away, writing on it, those would all be physical changes. Dyeing it, coloring it, whatever. So let's keep going. Explain how intensive properties are different than extensive properties, right? We know extensive properties depend on the amount of matter in a substance. Intensive properties do not. So intensive properties, more like color of something, right? Something's color is not going to change. If I have, if this cup weighed 10 grams more, it would still be a black cup, right? So that would be an intensive property, would be the color, whereas the mass of it would be an extensive, because that will change. If I add more mass or add more matter, my mass will change, okay? Excellent. Next question says, what is the SI base unit for mass of a substance? Some of us missed this because we put moles, because there was a question on my expectations or somewhere. I don't remember where I had it, but we talked about the amount of a substance as moles, right? But for mass, we know that that's kilograms, okay? So your answer here would be kilograms. Continuing on. Okay. Explain how you find the average atomic mass of an element. How you find the average atomic mass of an element. I would have accepted several answers here. You could have written out and explained that you multiply the fractional abundance or the relative abundance times all the masses of each isotope and add those together. That would work. Some of you just gave me that formula. Atomic mass equals sum of A1M1 plus A2 M2. And I'm going to give you guys a little piece of advice for these essay type questions right here that have this huge gap, right? Or this huge submission that you can write. You can put subscripts in there. So you could make yours look like that with this. Or if you need to write something on paper, you can write it on paper, take a picture of that and upload it as your answer. Just upload a picture, right? That works for me too. As long as it's in your handwriting and I can tell that it's yours, that's fine with me too. So you can upload a picture by going to this right here, insert/edit media. So you can either upload it if you get it as a source file, but you could also just go embed image, right? So when you hit embed image, you can hit canvas and then hit upload file, okay? So you can upload a file. So you'd hit my files, upload a file. It would be on get it on your computer, however. If that's too much, don't worry about it. So that's just a little piece of advice there. Continuing on, question 7. This one tripped up a lot of people. Let's read this problem and interpret it through a break it down. What are we asked to find, etc. Explain why chlorine has 2 isotopes, but the average atomic mass is 35.45. It's not explain why it has 2 isotopes. It's explain why there's 2 isotopes. However, those 2 isotopes, the mass is not directly, or the average atomic mass is not directly the average of both. Because if it was the average of both, it would be 36, right? But it is the weighted average. So what I'm looking for here is for you to say something about it being a weighted average, or chlorine 35 being more abundant in nature, or it has a higher relative abundance. Just explain why that average is not dead smack in the middle. It's not 36, okay? So that one was a little bit tricky. Not tricky, but it just requires you to go in depth. When in doubt, go in depth. That will help you as you do these problems, okay? The atomic mass of an element is simply the average mass of its 2 atoms. No, it's not. It's what? It is simply the weighted average mass. Excellent. Of its 2 isotopes, right? And not necessarily 2 isotopes, of all the possible isotopes, okay? So, continuing on. That's not going to go away unless I clear it. Excellent. So, what unit do we use to find the average atomic mass of an atom? I accepted several answers. AMUs, atomic mass units, Daltons, right? Or U's, right? Those were all things that you saw in your Edmentum. I accepted all of them. Okay, continuing on. How many protons, neutrons, and electrons are present in the following ion? Oh, some of us missed this and it made me sad. Well, this is a ion or an isotope for mercury, Hg, okay? So for mercury, what are we looking at? We're looking at a mass number of 190. We know that mass number is equal to the number of protons plus the number of neutrons, right? And this number down here is the atomic number for mercury. So we know straight away that P plus, there are 80 protons. And then if we apply that to this formula, 190 minus 80 equals 110 neutrons. And then finally, we have a 2 positive charge, which means we must have 2 more positive charges than we do negative charges. And what we know about atoms is that we cannot add or subtract protons, but we can add or subtract electrons. That's right. So that would mean your electron number would be 78, because that's 2 less than your proton number, therefore creating more positive charge. Now, I saw a lot of people put 80, 120, and 80, okay? I'm not going to assume anything, but I just know that if I were to Google this question, that's what I would get. And that's because that's for a standard atom of mercury. Now, this is an ion and an isotope, so please don't just trust Google. I'm not saying you can't use Google, but sometimes that'll bite you, right? Trust yourself, work out the problem, use your brain, because I don't, if you notice, that's my handwriting. I create this problem, right? I don't rip a whole lot of problems offline. So if you can find it online, okay, but trust yourself, okay? Cool. Continuing on, because a lot of us got that wrong because we Googled it. Now, this problem, question 11. Everyone got 1 point for just answering it, right? That was just a little happy bonus I did here. But this is where we apply that formula we wrote down earlier. Atomic mass equals A1M1 plus A2M2. So let's do this problem. I want a little thinner pen. Let's do this problem for what we're given, okay? We are solving for atomic mass and we're given the abundance, okay? So let's convert that first abundance to a decimal. Oh, wow. This is going to make me mad if I can't write in a simpler, smaller. Will you let me, please? 0. No, it's not going to let me. Let me try this one more time. Draw small. Nope. All right, we're just going to go with this fat eraser or with this fat pen, and we're going to do whatever. That's what happens when you use the features in Zoom. Anyway, so let's take our initial abundance as a fraction, 0.8082 multiplied by the mass of that isotope. That is 19.99. And you add that to the same idea, the fractional abundance of your second 0.0526 multiplied by, geez Louise, Mr. Lee, come on, step it up. All right, multiplied by the mass of your second isotope, 20.99, okay, times 20.99. And then finally, you're going to add that. I'm going to put a parentheses over all that. Then finally, you're going to add that to the same for your third, 0.1392 multiplied by the atomic mass there, 21.99. When you plug that into your calculator, you get the answer. I don't know off the top of my head. It's like 20.3 or something like that. But yeah, you guys will be able to see the answers on yours. So if you're still confused about that, reach out to me. But that's how you do that problem. Now, let's knock our last problem out because this one probably had the most, I don't know percentage-wise, it was the, what am I doing? Okay. I don't know if percentage-wise this was the most missed question, but I know that a lot of us struggled on this one. So hopefully we can understand what we're doing here. Basically, we're given two isotopes, right? We don't know their abundances. We do know their average atomic mass. We need to calculate those abundances. Whenever I see that, remember we have that 100% equals X plus Y. If you watch my Zooms or you come to my Zooms, you would have seen that. So that we can isolate X and Y, we can assign those as variables in this problem. That's the kind of problem we're dealing with here, okay? So first things first, our first mass, right? We know that atomic mass is what we're asked to find. What are we given? We are given the mass of isotope 1, or we'll call it, stop that. Stop. I hate these pens. Oh, here, how about this? No, that won't work. Yes, it will. Watch this. Boomtown. I'm going to screenshot this. I'm going to rip it over here. I'm going to paste it right here. Oh, yeah. I'm going to share my whiteboard. Life is good. Okay, so much easier. Jeez Louise. Okay, here we are. Let's solve this problem now that I can use good pens over here. So knowing what we know in this problem, let's write it down from what we're given. Isotope 35. Now I have to switch my pen to work on this screen. Sorry about this, guys. Perfect. So knowing what we know about this problem, we know that the mass of isotope 45 is equal to what? It is equal to 44.992. We know the mass of isotope 40, what is the next one? 43 is equal to 42.9747. We know the atomic mass, geez Louise, we know the atomic mass is equal to 44.44. So what we need to do, we need to solve these by plugging them into that formula. AM equals M1 times A1 plus M2 times A2. So we need to plug these values into that formula, solve for those abundances. We'll be rock and roll, okay? So 44 is your atomic mass. 44.44 equals, what do we have this equal to? 44.992. Do I know A1? No, I don't. A1 equals question mark. A2 equals question mark. Remember, we're going to assign those to be X and Y because it makes our problem a lot easier. You don't have to, but that's what I do. So A1 is going to be X, okay? 44.992 times X, and then plus 42.9747 times Y, okay? We know from that thing that I showed you earlier that 100% is equal to those two abundances added together. So 100% is equal to X plus Y. When you isolate and solve as a fraction, not a percent, you ultimately get 1 equals X plus Y. Isolate for X, so then we get 1 minus Y equals X. So that's what we're going to do. We're going to plug that value in there for X. So now we're dealing with 44.44 equals 44.992 times 1 minus Y plus 42.9747 Y. Okay? Isolate, or not isolate, distribute that to both parts of the parentheses. And so we're going to be having 44.44 equals 44.992 minus 44.992Y plus 42.9747Y. Okay, let's add those two values together. We're left, and then let's subtract that from both sides. Whoop, I'm going to erase that. We're going to subtract that from both sides. Nope, need a skinnier pen. Minus 44.992. When we do that, minus 44.992, you get some negative 0 point. Calculator, Mr. Lee. Where's your calculator, Mr. Lee? There it is. 44.44 minus 44.992. You get negative 0.552 equals, that canceled. These two values added together, negative 44.992 plus 42.9747. So you get equals negative 2.0173 y. Let's solve for y. How do we do that? We divide both sides by negative 2.0173. Okay, whenever we take negative 0.552 divided by negative 2.0173, what are we left with as an answer? We are left with 27.36%. Okay, now you're like, Mr. Lee, that's not the answer. You're exactly correct, because that's the answer to y. What is y in this case? Y is the A2, so y is 43. So what we need to do now is subtract 100% minus that answer, 27.36%. So when I take 100 or 1 minus, I get the answer 72.63%. That is the value for x, which we know x to be A1. We know A1 to be 45. So whenever you come over here and you plug that into your answer here, you get 72.63. And it says as a percentage, so that means if you put in the percent value, look what happens. So I put in percent, only numerical values are accepted. So it runs away, okay? So you have to make sure you just put in the numerical value, 72.63. That's the answer to that problem. I know it took a while. Hopefully you get this down, you watch this video, you take notes, you make note of what you made a mistake on, so that for the test, whenever we see this again, you don't make those mistakes. That's all for today. Have a great day. I will see you on Monday or Tuesday. Goodbye. Or I guess you're probably watching this on Monday or Tuesday. I'm making this on Friday. See you whenever. Bye.